In this session, we're looking at HSC Mathematics 2015 paper, question 13, part B. The section 2 of this question, section II, was the part that many students got wrong and couldn't solve it properly. So it was one of the common mistakes in that HSC paper. All right, let's have a look at this. Find the domain and range for the function f of x equal to square root of 9 minus x squared. We know that for a square root to be meaningful, we need to have whatever under the square root to be larger or equal to 0. 9 minus x squared should be larger or equal to 0. That suggests that x has to be between minus 3 and 3. So that is our domain. As far as range goes, by definition, square root is 0 or a positive value. So your range will be y greater or equal to 0. So that's the domain. This is the range. As for the second part, where many students got this wrong, on a number plane, shade the region where the points x, y satisfy both of the inequality y less than or equal to square root of 9 minus x squared and y greater or equal to x. So what we need to do, we need to ignore the inequality and look at it if it was an equation like this. Y equal to square root of 9 minus x squared. And we can square root both sides to get y squared equal to 9 minus x squared, and move x squared to the other side to become positive, and you get x squared plus y squared equal to 9. You know that this is a circle with a center at origin and a radius of 3 units. However, this is only a semicircle because y has to be positive. So when we are graphing this, if this was your y-axis and this is your x-axis, we are talking about a semicircle with a radius of 3. That is our semicircle, if that was equal. But we want y to be less than or equal to that. So that means I can take anything inside this plus whatever falls in, if I draw a straight line, a vertical straight line like this, and whatever inside that. Because as I go down, say for example, we say this point is a point inside the semicircle and it's acceptable. Now if I go straight down, what is happening, x stays the same if I go vertically down. So that means x squared is the same, so 9 minus x squared stays the same, but y decreases. So y already was less than square root of 9 minus x squared here, so it will be less than that also as we go down. So that region, if I shade, will satisfy y less than or equal to square root of 9 minus x squared. As for y greater than x, if I draw it in a separate Cartesian plane, again assume this was an equality, y equal to x, and that is going to be the line y equal to x. But here we want y to be greater than x. So that it means we got to go above that line. So that is the region that we are talking. Now if we want both of these inequalities to be satisfied, then we need to look at their intersection. And if we draw them on the same Cartesian plane, that will give us this circle with this straight line, and then you have this the line y equal to x, and we are interested in all points above the line if they lie inside this shape. So that gives us this shaded area. Okay, that is the solution to this question. And one of the recommendations of the Board of Studies was that when sketching the curves, try to make them at least 1/3 of a page and use rulers so you get a more accurate graph. Thank you for your attention.